Okay, so when you think of the stuff we breathe in, the stuff that surrounds planet Earth, that makes our atmosphere, okay, the thing that we call air, do you know what it really is? You can define air as a combination of gases, like oxygen and nitrogen, and carbon dioxide and some hydrogens mixed in there and some ozone gas, and all these things are mixed together, but they're all in their gas state. And when you hear about this thing called air, you can't see it. You're touching it, but you don't know you're touching it. You can feel when it's hot or cold, when thermal energy is involved and it changes its temperature. You can kind of notice it. If it gets mixed with water vapor, we feel it, we call it humidity. But the thing is like, is it matter? Is it like considered a substance? Is it made of particles? And you could say yes, because it's not energy, so if it's not energy, it has to be matter. But here's the thing. How can we prove that air is matter? Well, look at this beaker. In this beaker right now, what's inside of it? Okay, air. Okay, can't see it. Okay, can't really measure it, because if it's gases, that means it's spreading out throughout the entire container. Okay, if I take my hand off, it's going to now expand out of the container. Okay, that's great. Okay, we remember chemistry. Matter is something that has mass and takes up space. But it's hard to put this on a scale, even if I put a lid on it, and find the mass of the air. Okay, since we can't see it, it's hard to understand that it is taking up space inside this beaker. But what I'm going to do is I'm going to do something that's going to kind of show you that the air is taking up space. And if it's taking up space, it has to be considered a form of matter. So what I'm going to do is I'm going to take this regular dry crumpled piece of construction paper and I shove it inside this beaker. And what I have set up over here is I have another beaker that's filled with water. I added a little bit of blue food coloring to the water just so you could see it better. Okay, so here is our paper inside of this beaker. So right now this beaker has paper and air. Okay, now I'm going to take this beaker upside down like this, and I'm going to push it into the larger beaker filled with water. As I do, you can see that water is spilling out of the large beaker. Okay, and when I take this out from inside, okay, and you look at the paper that's inside, it is still dry. Okay, you don't believe me that it's dry? Here's this paper dry. Here's this paper wet. Okay, much darker. It doesn't seem to have that color. So yes, we have dry paper in here. Okay, so think about it. Why did this paper stay dry? When I went like this, look what happens to the water inside the large beaker. It gets pushed out of the way. Why would the water get pushed out of the way? Well, you'd say maybe because the smaller beaker is taking up space, but is it really taking up that much space? If I shatter this into pieces and put those pieces into this large beaker, it would only rise up about that high, not to the point of spilling out. And maybe you're saying, well, Rolis, it's because your fingertips are going into that water. But again, not enough to really make the water displace out of the large beaker. So there's something else inside here that is taking up enough space where the water inside this large beaker is being forced up and out. And that, my friends, is air. To prove that there's air in here, we push water out of the way, because the water and the air cannot occupy the same space at the same time. Since the air can't occupy the same space as the water, then that means that air, well, it has to be made of particles and has to be considered matter.